Okay, so the final video for today's lesson is going to go through questions 31 and 33. Both of these, I'm sure you've spotted, are on implicit differentiation, aren't you? Differentiating something where you have y's involved in the equation as opposed to just being y equals something. So remember that what you do is you differentiate, and if there is a y there, you differentiate the y, but you just shove a dy by the x after it. Okay, so find the coordinates of the turning points on the curve y cubed plus 3xy squared minus x cubed equals 3. So remember, this means turning points are where dy by dx equals 0. So what we're going to do here, we're going to get dy by dx using implicit differentiation. We're then going to set it equal to 0, and we're then going to have to try and use that to figure out the coordinates at those points. So let's have a look at differentiating this first. If I differentiate y cubed, that's going to give me 3y squared, and then because it was a y, I have to put a dy by dx. Plus, when I differentiate this thing, I would always, when the y is sort of multiplied by the x, I'd go and use the product rule, just to make sure that I'm getting everything right. So if u is 3x and v is y squared, then du is just 3, and dv is 2y dy by dx. So u dv is going to be 6xy dy by dx. Plus v du, which is just 3y squared. Minus differentiating this thing is going to be 3x squared. Equals differentiating 3 is 0. Okay, so that's what I need. I now need to isolate the dy by dx's, so I'm going to take these two terms over to the other side and then factorise out dy by dx from those two. So that's going to give me 3y squared plus 6xy dy by dx on the left hand side, and 3x squared minus 3y squared on the right hand side. So dy by dx is going to equal that over that. Okay, so if I want the points, the turning points, it means that at this stage that needs to equal 0. So 0 will equal our gradient function there. Now, whatever's on the bottom of the fraction, it needs to be the top that equals 0 there, doesn't it? So I'm going to I can basically just ignore the bottom of the fraction, and I'm going to divide both of these two things by 3. So it's going to give me the equation 0 equals x squared. Why did I put a plus at the top there? Sorry, that should be minus, shouldn't it? Up there. X squared minus y squared. Okay. Now, obviously at this stage we could normally solve this. We would normally solve it in terms of x, wouldn't we? We can't solve it to get x as being a number, but we can solve it to get x in terms of y. So it means that x squared will equal y squared. So square root on both sides means that x is going to be plus or minus y. Okay. Now that means that the turning points occur when x equals y and when x equals minus y. Now what that means is that I can sub that into this at the top. So if I let x equal y, the top thing then becomes y cubed plus 3 times y squared minus y cubed equals 3. Okay, which gives me y cubed plus 3y cubed minus y cubed equals 3. Simplify all that out, you're going to end up with y cubed equal 1, which means that y is 1. And remember, right the way back at the start of this, we said that x was the same as y. So if y is 1, then x must be 1. So that gives me the coordinates 1, 1. Okay. I'm now going to do the same thing for minus y. When x equals minus y, you're going to get y cubed plus 3 times minus y squared minus y cubed will equal 3. Now, this time, sorting all that out, we're going to get y cubed minus 3y cubed plus 1y cubed, which will give us minus 1y cubed equaling 3. which means that y cubed is minus 3, which means that y is the cube root of minus 3. And for this one, remember that x was minus y, so it means that x there will be minus the cube root of minus 3. So the two coordinates are 1, 1 and minus the cube root of minus 3 and positive cube root of minus 3. There are your two coordinates there and there. Okay, so getting down to this part here I think is quite easy. This is a little bit weird getting from there down to there, I think. Okay, so that was question 31. Let's have a little look at question 33, talk you through it, and then you can go away and have a go at it on your own and come back and we'll check it. So a curve has equation this. A and B are two distinct points on the curve, and at each of these points the gradient is 2 over 11. Use implicit differentiation to show that the straight line passing through A and B has this equation. So what you're going to do here is you're going to use implicit differentiation to get your gradient function. This time it isn't a turning point, it's when the gradient is equal to 2 over 11. Okay, so instead of setting it equal to 0, you're going to set it equal to 2 over 11. Rearrange all that and hopefully it will look like this. Okay, so have a go at that now, pause the video and then come back and we'll go through it together. So hopefully you'll be able to have a good go at that. Let's have a little look at what we're going to get when we differentiate this. So that's going to give me 14x plus, I'm going to use product rule again for this one, u and v. So du is 48, dv is dy by dx. So u dv is going to give me 48x dy by dx. Plus v du, which is going to give me y times 48, which is 48y, minus 14y, and then because it's a y, dy by dx, equals 0. 75 just disappears, remember. Okay, so I'm going to do exactly the same thing as I did above. I'm going to get everything without a dy by dx onto one side, everything with a dy by dx onto the other. Because I've got these two things as positive on this side and that's a negative dy by dx term, I'm going to take them over there. So that's going to give me 14y dy by dx minus 48x dy by dx equals 14x plus 48y. Okay, so factorising those two things out and putting them underneath, we're going to get 14x plus 48y over 14y minus 48x will give us our dy by dx. I've skipped a couple of steps there. What I've done is factorised out the dy by dx is there, and then the bracket has gone underneath there. Okay, and remember I wanted this to equal 2 over 11. So 14x plus 48y over 14y minus 48x will equal 2 over 11. Multiply that out, so 11 times both of these, that's going to give me 154x plus 528y, I think, yeah. Yep. Equals 2 times 14, which is 28y minus 96x. If we bring all this onto one side, this is going to give me 154x plus 96x, which is 250x. 528y minus 28y is 500y. And then simplify that, will be x, add 2y equals 0, and that was what we were trying to get to. Okay, so well done if you managed to get that one right.